Hello guys, in this video I will show you how to do the basic RBD setup. So I made a few changes from the previous video. It's not major, so I'll walk you through it. First is the camera. I changed it from 1080 to 2048 by 858 to give it a more cinematic feel. You guys can leave it at default 1080 or you can copy my settings here. It's up to you guys. So let's see what I did for this part. QC, press F. I took the original file that I cleaned up and exported separately, and I blasted the parts out. So this is the specific part where the destruction is going to happen later on, so I want more detail there. Therefore I'm going to fracture them separately. Later I'll show you guys. How I blasted them out is I click here, click the selection tool here, and it turns into this color. You guys can select these, control to deselect, and then simply press delete and you have yourself a blast node. If you want the opposite of what you selected, you click delete non-selected and you have your two parts. That's all I did. Moving on. First, we're gonna put a null here. Call it out hull. Copy paste and name this out bulk. You guys don't worry about the animation yet. We are going to have to put the animation after we fracture them again, so let's just leave that there. Put down a new geo node. Call it destruction 1 prep. Jump inside, put in an object merge. Click into this object and bring in your out bulk and your out hull and merge them together first. Okay, now you have your spaceship inside a new geo. Then we are going to start with the body, the out hull first. Sorry. Name this hull. Okay. Scatter some points. Turn off relax iterations to get more variety and maybe bring this down a bit. Okay, looks good. Put down a Voronoi fracture. Plug the first input into your object and the second input into your scatter. Let it cook for a while. You have yourself few fractures. Maybe it's too much, so might want to decrease it a bit, say 300. Okay, this is gonna be the base. We are going to vary things up by putting an RBD material fracture. Okay, it finished cooking. So you guys can see here first, there's a few choices for you guys to pick: concrete, glass, wood, or custom, but I'll just stick to the default concrete. And you guys can see all the different fractures ranging from big, which is our Voronoi, and our small, which is the RBD material fracture. Okay, what I want to do first is decrease this because I think it's a bit too much. Okay, there's less fracture pieces. If it's too much, you can always decrease this, but for now I think it's okay on detail. You have big pieces, you have small pieces. You guys can enable chipping if you want. This will give you even tinier more, but I think so far so good. If you guys feel like the edges of the Voronoi fracture are very sharp, you can maybe try to subdivide the body to get more resolution on it. But as you guys can see, it goes very soft. So switch this to open subdiv bilinear. Okay, and scatter those here. You can see the fracture pattern got larger, and we'll have to recook this obviously, so we'll just wait for a bit more. Okay, it's done. You can see it's a bit different. Since we added extra lines, there's more space for them to go in between. And the fractures vary. As you can see, even very tiny pieces over there. So you guys can add more or add less. But I'm happy with this one. So what I like to do after this is file cache it out. File caches. Name it hull fracture.bgo.sc. You don't have to use $frame because you only want one frame just for this. Okay, so load from disk. You can see. So I did this because I don't want the RBD material fracture to cook for quite some time. Every time I do a simulation or I run an iteration in the .NET later on, so it's gonna be a hassle. With this file cache, it just reads back from the file I've saved in my directory, so it's way more efficient. Okay, onto the bulk. we want to do the same, but I think a Voronoi is enough, so just put down a scatter first. Okay, here too many, so bring it down to maybe 70 relax iterations and put down a Voronoi fracture. Plug the first input into the object, plug the second one into the scatter, and oh, you can cut using Y and you just drag. So plug this back in, and yeah, if it's not enough for you guys, you can always increase the scatter number, maybe 90, maybe a bit more, maybe 20. Yeah, if you guys want some chipping on it, you can put down the RBD material fracture as I've shown you with the body part, but I think it's enough because it's very far away. Okay, and put another file cache. And file cache out one frame. Yeah, and now you are settled with your fracture pieces. There's a lot of detail on the body and less on this, but it has many tiny parts, so these will also break apart anyway. If you guys want to check, you can put down an exploded view. And there's all your pieces. Uniform scale to bring it down. These are gonna fly off very far when they get destroyed later. So there's big chunks, there's tiny chunks, which is a variety. So let's move on. Before we do that, we need to put down the animation again, so go to your spaceship part, top destruction, Control C, go here, Control V or animation, and it is moving again. Okay, the next order of business is to create an assemble node. For this assemble node, we are going to use it for the glue, so we need to create a name attribute and connect the edges, inside edges. Do not create packed geometry because glues cannot work with packed geometry. So to the side, create a connect adjacent pieces node. Plug it in. As you can see, this is the base of your glue, which is not what we want. So we want to switch this to adjacent pieces from surface points. Okay, this looks good. Now we are going to create an attribute wrangle. Run over primitives, and I'll explain to you why we switch that to primitives later. So what we want to type is as at constraint underscore name equals to, you can name it as whatever you want. I'm gonna name it as glue and close it. we need to put this as double quotation. Okay. Enter an s at constraint type equals to all. Put an ending there too. Okay, so why I switched this over to run over primitives is because if you select a glue piece, you can actually blast it away, like what I did to the spaceship. So the spaceship is a geometry, and this just proves that the glue is also a geometry, a primitive. So you can undo that, and yeah, don't forget to change this, if not it won't work. So next is to put down a null, call it out constraint out cons1 to make it short. So okay, and now we are going to prep the spaceship to bring it into DOPS. For this, we are going to put down another assemble node, escape to escape from those colors, and with this you want to create pack geometry. So you want to pack this, create an wrangle again, name it I at active equals 1. It's okay, looking good. And we are gonna name this out instruction 1 pack. Okay, this is our basic small setup, and as you guys can see, active name points, so everything is settled. There's the name, there's the active, and now we can jump up and create a .NET. In here we are first gonna put in a RBD packed object, bring in our spaceship, which is out destruction pack 1, except put down a bullet solver, connect it to the first input, connect this there, and you can see the spaceship is in, the top part is in. Next we are going to put down a constraint network for our glue. We are going to bring in our glue out cons1 except, and we are going to put down what's called a glue constraint relationship. Plug it to the second input, and in the data name you want to change this to what you named your glue. So as at constraint name, that's your glue name that we created in the attribute wrangle. So I named it glue. It has to be the same spelling. Okay, and we are not going to meddle with this first. So as you can see, there's the glue. If these red lines are not showing up, that means your glue isn't reading into the .NET yet. So probably want to retrace back the steps of what you just did. To not visualize this, you click Constraint Network, Guide Options, and uncheck Show Guide Geometry. Okay, let's test this out. Okay, wait a moment. Should see from the camera. And the animation is gone, which is probably something we need to check. Assemble, still moving. Assemble 2, still moving. I at active equals 1. It's still moving. Okay, so maybe put down a gravity. It's supposed to drop, so maybe that's the cause. Yeah, now it's dropping, which means everything is working, the simulation is working. But now the problem is we don't have our animation. And how do we fix this? So you go here, you have this override attribute, check this on. You can see the 3 attributes: active, animated, and deforming. We previously put down a wrangle called I at active equals 1, which means the simulation is active. 1 is active, 0 is inactive. So we just switch the simulation to active. But once it gets here, right, it didn't have its animation anymore. So what we want to do is create deforming active objects from initial object type and go back to our attribute wrangle and temporarily click I at active equals 0, I at animated equals to 0, I at deforming equals 1. With this, you should see your spaceship moving. Give it a sec to load. You can see it's now slightly moving. Okay, so that's how to get in your animation to the .NET. And now we are going to put in our collision, which is going to be a simple sphere. So create a sphere, rename it as collision 1, go here, click this button and ghost other objects, because you want to see what you're destroying and where you're moving your sphere. turn this into a polygon mesh. You can make it smoother a bit to get more resolution on it. Put down a transform node. Click this handle, and now you can move this around. So maybe scale this down a bit, 0.5, it's too big. Okay, that's okay. Alt click your translate, your rotate, and your scale in case you want to scale your sphere later. So this is the base. Let's say you want your destruction to start at the 14th frame. So, okay, let's just disable this for 1 second. For this, the start frame, you can just simply type 14. So your sim begins calculating at 14 frames above, because you want to have some spare frames. Okay, back to the collision. You keep this, so just key it at 14 maybe for the start, and then go press this brain button to disable sims. Go to maybe frame 30 and then just move your sphere up like this, making sure it goes through this part. So I'll click and you can see your animation playing. If you don't like where it's coming from, just shove this there a bit. You can right click, delete keys. Now you have your base animation. Maybe make this go a little further so it doesn't interfere with the destruction later on. And put down a null. We are going to bring this into the .NET now. Name it out sphere 1. Okay, jump in your .NET. Reset the sim. Bring this down. Put down a merge. Put down a static solver. Make sure to switch this around, because in the .NET everything gets calculated from left to right, so you need to be careful with this. Okay, everything looks fine. Put down a static object. Reset the sim. Click on use object transform and create active objects, or even you can click this on just to make sure of it, that the object that you're bringing in is going to have animation. So active object is creating it as an object that's moving. So point this to your collision 1. Subpath is your sphere. Go to the collisions, you can check this, uncheck display geometry, hide other objects. It's not reading in because it's not in the beginning of the simulation yet. So let's see what we are doing wrong here. Maybe change this to polygons. Increase the frequency. Should be fine. Oh, there it is. Forgot to uncheck this brain. So now you have your sphere inside. You can check your collision first, which is perfect collision. You can uncheck this because you don't want to see the sphere when it goes out later. You just want to see the spaceship getting destroyed. Okay, second thing is we want to check this collision too, so it's getting proper interaction with the sphere. So show guide geometry. It might take a while. Now look at that. This looks horrible. So we are going to fix this by shrinking these down. Linear threshold. And you want to bring down the collision padding. Bring it down even more. Just a bit more if you want. Okay, the collision looks better. Now we can test it out. Uncheck show guide geometry and display the geometry again. And for now, I know this is going to cause a problem, which I am going to show you what the problem is right now. And it is this. So wait for a moment. So you can see the sphere is not interacting with the spaceship. Why is that? Because as you can remember, we put I at active equals 0, so the simulation isn't working. So now we are having problems with it. But the other issue is when we put I at active equals 1, the whole spaceship just drops. So I have a tiny solution on how to fix this. Go here, create a group, put it in, uncheck this, and check on keep in bounding regions. So you can see this box, and put your moving tool here and drag this up. you can see the place you are dragging is getting highlighted yellow, which means you are selecting this specific area only. Select a bit larger, maybe a bit to the back, and here. Okay, that should be good. And what you want to do is name this group. You can name it active. Okay, so now you have a group called active, and ask like, what do we do with this? So we put down an attribute wrangle again. We go here, just take this code, put it here, but change the I at deforming equals 0 and turn the I at active equals to 1. And what you want to do is select your active group. So this attribute wrangle is going to run only over this group. So the tiny box that you selected, this one with the yellow parts, it's going to affect only those yellow parts. So let's test it out. Main camera. Yeah, as you guys can see, this part is getting affected while the rest is still moving very slightly, as you guys can see. Spaceship, it's not dropping, so wait a moment. Oh, you need to delete channels and make this 0, I think. Let me just check. Yeah, so now the pieces are traveling freely and they're dropping for now because we have this gravity. So this is the basic setup. On the next lesson, I will be research and developing the look, R&Ding. So stay tuned to see the final results of the destruction.